My name is Fred Slane with the Space Infrastructure Foundation. Thank you for listening today to our YouTube presentation on how to use a space reference architecture. Let's start with some background material, introduction, and things you need to know about a reference architecture. So this application is based on an open and established methodology. It goes back many, many years. Important notations here are that the current architecture description document is part of systems engineering in ISO and IEC and IEEE on software systems and enterprises architecture description. What we've done is a community of us has gotten together and refined the methodology, worked directly on space systems. So we have a reference architecture for space. This is based on a product, the Reference Architecture for Space Data System. It was first published in 2008. Space reference model includes all space objects in the space domain, spacecraft, launch vehicles, ground segment, all of those things. And the space reference model includes all space stakeholders. The original Reference Architecture for Space Data Systems, RASDAS, was an informational document from the Consultative Committee for Space Data Systems. And that community is working primarily in the area of space data and information transfer. Viewpoints for that community that they felt needed to be established as core were enterprise viewpoint, connectivity and deployment viewpoint, function, the information viewpoint, and a protocol viewpoint. The addition of considerations for systems and operations led to the addition of some more viewpoints. And you'll see now that we have a services viewpoint, and this is where we might include such things as a SOA or a services-oriented architecture, be consistent with the reference architecture for space. Also added an operational viewpoint and some detail on physical viewpoints. We've specifically identified systems engineering practices and standards as being based on 15288 ISO and mission assurance viewpoint similarly. So we're building off of established information and protocols as we can. So with these core viewpoints, I should emphasize that these are core. Individuals can add viewpoints if they find they're necessary, but we think most people can catch most aspects of space systems under these viewpoints. But you see here the interrelationship between, for example, enterprise and operations, or enterprise and the component. How the operations sequence of events might be established as some functionality, but this is also tied to components and how they operate, and then the sharing of information and the structure of information. So we have an interrelationship here that we can follow as we develop new knowledge or capture existing knowledge and put it into the body of knowledge for space architecture. This slide helps us understand the interrelationship between the viewpoints, life cycle, and scalability. And I'd like to specifically thank Koki Asadi from Japan Space Systems for putting this graphic together and helping us understand how these things interrelate. You might question why we need a reference space architecture. And some of the reasons are relatively straightforward. So helping all participants understand modeling and articulating challenges, helping coordinate serial and parallel process developments across organizations, basically between organizations, between countries even. So we need to be consistent and with a multitude of standards and various standards development efforts. And this is ISO SC14, ISO SC13, also known as CCSDS, but other organizations, ISA with ECSS, NAA standard, ASTM standards, any standards that are out there that help us describe bodies of knowledge that are known and shared. So this helps us avoid superposition of subjects, just because we don't name things the same way, and so we have same description but different names. Identifying cross issues, and this goes back to the spaghetti chart with the interrelationship between the different perspectives. I'd like to also make the point that as we get into modeling and we get into digital environments, model-based systems engineering, for example, we need to have consistent language so that we have interoperability as applicable between different modules in our modeling structure. And this is done under the reference architecture for space without regard to proprietary information or without establishing proprietary information. This is an open knowledge base. So with that background information, I'd like to go through an example here where we've taken this structure and applied it to a particular need. So we're going to use, in this case, a space reference model, a diagram as a starting point. This is often the starting point for use of this specific need. This diagram shows us models for us, although it's a rather primitive PowerPoint structure, not a real engineering document, but it can be built into engineering models, where we talk about all the different components of what's going on in space. We'll see that while we have things like spacecraft and launch vehicles and ground segment, and they interrelate, we're talking about planetary, we're talking about EVA, we're talking about human spaceflight, and all of those different things. We're wrapping that or basing that on a systems engineering understanding. And as I said earlier, the systems engineering standard we're using here is 15288. The need is for everybody to share a common understanding of systems engineering. I think which is not unreasonable. And then we've based that entire systems engineering structure for space within the space enterprise is things that are of specific use in space. And that leads us to, in the future, relating with enterprises that are not space. So, for example, space systems providing imagery to a terrestrial environment where remote sensing information is used for automotive traffic and so forth. So, those kinds of things. With that very broad description of the space enterprise, we're now ready to start to look at an area of specific interest. And face it, every one of us, every participant in the space industry has an area of interest. It might overlap with others, it might not overlap with some others, but everyone has a starting point of their interests. So the example I'm using here is what we used for on-orbit servicing. And there was a consortium formed several years ago, the Confers Group, to look at on-orbit servicing and standards development. And this is the flow that we used. First, the community established what an on-orbit servicing mission would look like. And we got into this in some level of detail. So the diagram you see here is actually a reference, or excuse me, an extraction, or from the reference architecture space reference model. We have here spacecraft such as a servicer spacecraft, and we have a client space object. We have rendezvous, proximity operations, capture, a bunch of servicing functions that can be applied, and then separation, return to parking orbits, or for survivability and sustainability, the deorbiting of either a client object or components of a client object when a spacecraft has been serviced. This is a picture. We talked about the picture quite a bit. You'll see here there's a little green arrow on 7.1, proximity operations. I want to look at what we did with that piece next in the elaboration on this on-orbit servicing mission. The text in the standard for on-orbit servicing at its highest level, ISO 24330, we defined what's going on in these phases. Not definition in the sense of exclusion, in the sense of this is the kind of activity that's occurring and the kinds of objects. In this description, you can see highlighted in yellow some component objects, like spacecraft, client space object, which could be a spacecraft or a natural object. We've got onboard sensors identified. We've got the servicer spacecraft identified. So we built those in and described them and defined them. Also included are operations objects. And these include things like the proximity operations phase, yes, relative operations, relative navigation, transitions from normal mode to support servicing mode. And so these are things that we defined in that language. On this slide, basically what I'm outlining is some of those things that we identified in those descriptions. Now, ISO 24330 was developed under Working Group 3, which is for operations and ground support, and really is not directly involved with component design, spacecraft design, for example. So you can see that while some of these things are directly related to the operations working group, some, such as spacecraft interfaces, be dealt with in another area and a different set of subject matter experts. And that's okay. Those are the things that we need to know to move forward. Going back to the relationship between the different viewpoints, we can see that when we have an operations activity, there's a functionality, performing something for the space enterprise, yes. There's a functionality that's being defined there, and that can be broken down into what components and what connectors and what part of the space environment that function is taking place in. So we might have an operations standard, but we have implications for component standards, and we have implications for connector standards or interfaces. And these are examples then of how we use reference architecture to have a methodology for this interrelationship, and we don't have to invent it each and every time. So at this point, we've gone through an example. We started with a space reference architecture. Now it's been developed in a particular aspect to a greater degree of detail. So it's important to capture that information and feed it back to the space enterprise community, spacecraft designers, what have you, spacecraft operators, so that that information is carried forward. A large part of that is what we do in standards. And of course, as I should have mentioned earlier on the diagram between different viewpoints, a standard then becomes a information object, although of a particular nature, it would be captured also in the operations viewpoint. Here we are. We have a very simple diagram, but implications of what sits behind that in terms of going from PowerPoint to an engineering diagram where each object is identified with particular characteristics, attributes, and so forth, is it's the heart of the methodology under RASDIS++. So I invite you at this point to start to think about looking at those details in RASDIS++ and understanding these interrelationships in that specific language. We're going to, at this point, begin to look forward at how we iterate reference architecture from the as-is. An environment where we have new standards, new information objects, if you will, about operations and systems and connectivity, about the space environment, about services that are provided, about how organizations work within the space enterprise at a fully international level, a global level, or down at a regional level. This leads me to some pieces of background information. I'll let you look at those yourself. There's no audio that goes with that. But I want to remind you that the functionality we're going to get here is as we share models, whether those models are simple graphics or those models are more fully developed and systems engineering based, we're now able, through the reference architecture, to share information among different groups, different working groups within ISO, for example, different mission groups, different agencies, and all of us move forward as a product of all the individual efforts that are brought into and under the reference architecture. So thank you for listening. I hope this answered questions for you, and my contact information is on the front slide if you have further questions. Bye-bye.